Alright, welcome to page 5 of the notes. I know these are going to be awfully long, and they're going to get even longer because what we're going to determine now are finding other vectors that are part of basically the curve that we have, our vector equation. And so these vectors are going to help us determine what direction that our vector, not only does the tangent vector tell us where our particle is heading, the direction our particle is heading, but we'll have now other vectors, the normal and binormal, where it will tell us the direction that our particle is going to be turning, and our binormal and the other one's going to tell us binormal which direction our particle is twisting. And so let's just go ahead and define these vectors and how to find them. So at a given point on a smooth space curve R of t, there are many vectors that are orthogonal to the tangent vector. I single out one by observing that if we're doing the magnitude of if we're trying to find the magnitude of the unit tangent vector, well, of course that's going to equal 1 for all of our t's. That will give us that if we do the dot product of the unit tangent vector times the derivative of the unit tangent vector, we're going to get 0. And because we get 0, the unit tangent vector, the derivative of the unit tangent vector, is orthogonal to our tangent vector, or to our unit tangent vector. So what that helps us lead to is that because that the derivative of the unit tangent vector, because that is it's not a unit vector itself, but because that gives us a vector that's orthogonal to the unit tangent vector, what we can say is that if I take the derivative of my unit tangent vector and I divide that by the distance of the derivative of the unit tangent vector, then I'm going to get my unit normal vector. So this is a unit, meaning it's a distance of 1. And of course, because you're dividing it by the distance of the vector that we're taking of. So the way that we get the normal vector is just by taking the derivative of the tangent vector and dividing it by the distance of the tangent vector. And then to get the vector that is b of t, we're going to take the cross product of our unit tangent vector and our unit normal vector. And it's called the binormal vector. And it's perpendicular to both t and n, and is also a unit vector. So I'm going to kind of draw what that is before we actually get started. Say we do have a curve, in space somewhere. Well, if we look at, we'll zoom in on one point and we'll say, okay, let's find the tangent. So again, the tangent vector is just going to give us the direction our particle is heading at a certain point. So there's our tangent vector. Our normal vector is going to be orthogonal to our tangent vector. And so will be this vector. That is orthogonal, so a distance of 90 degrees. Or not distance, but an angle of 90 degrees of our unit tangent vector. So that's our, that's a normal vector, not necessarily the unit normal, but that's the normal vector. This is the direction of our tangent vector. And then what our binormal vector is, it's orthogonal to both the tangent vector and the normal vector. And what that's doing is, I'll just keep it red, is it's going in either one of these two directions, but we'll just take one. So just going in the other direction where it's 90 degrees from both. And so hopefully you're able to see that that's the binormal vector. That is going pointing away. All right, so there, hopefully you have an understanding of what the normal, the binormal, and the tangent vector are doing on our curve. I'm going to go ahead now, and we're going to calculate those. We're going to find the binormal and the normal vector. So we found tangent vectors before. We're just taking the derivative. So I will share this. It does take quite some time to find these. And so, for homework, I'm not going to, try to give you too many of these. And so we'll just start off with the first one, finding the tangent vector. So let's go ahead and find the tangent vector. The first thing that we're going to need is we're going to need to find, okay, what's the time? So what is t? And in this case, t is going to equal, what value for time will give us cosine of what time gives us 1? Well, 0. Cosine of 0 is 1. Sine of 0 is 0. And natural log of cosine of 0 is going to be natural log of 1, which is cosine of 0. Which is just going to give us 0. So now let's go ahead and find our derivative for r. So r prime of t is just going to be the vector. Derivative of cosine is negative sine. Derivative of sine of t is cosine t. And the derivative of natural log cosine t is just going to be negative sine t over cosine t. Which, again, I'll just point right here, and instead of having to rewrite it, it's just tangent of t, negative tangent of t. Alright, now let's go ahead and find our unit tangent. And so our unit tangent, let me zoom in some so I can make sure that I have plenty of space. Our unit tangent t is just going to be r prime of t divided by the magnitude of r prime of t. And so we're going to get our vector, we said negative sine t, cosine t, and I'm just going to say negative tangent t, all over the square root of this, which is going to be negative sine squared t, negative sine t squared plus cosine t squared, plus negative tangent t squared. And so this is just going to give us negative sine t, cosine t, negative tangent t, all over, save some time, sine squared t plus cosine squared t is just going to be 1. So we're going to get the square root of 1 plus tangent squared t. And that's equal to, now if you can recall, 1 plus tangent squared t is just going to be secant squared t. So I'm going to, once again, just point that is secant squared t. Let me move where I put that. Again, fast forward it if you think that you've got it. So therefore, we're working with negative sine t, cosine t, negative tangent t, all over secant squared t, square root of secant squared t, which is just secant t. And if you recall what secant t is just 1 over cosine t. And so, when I work everything out, I'm going to go ahead and multiply by, if I'm dividing by 1 over cosine t, I'm just multiplying the numerator by cosine t. So it's just going to be negative sine t, cosine squared t, and then negative tangent t is negative sine over cosine, so I'm just going to be left with negative sine of t. Alright, and there's my tangent vector. Alright, now to find my tangent at t of 0, so tangent of 0, so at my point, I'm going to substitute in 0. I'm going to get 0, 1, and 0. So there's my tangent vector. Not too bad. But now I get to find my normal vector. And in order to find the normal vector, I need the derivative of my tangent vector. So I'm going to take the derivative of my tangent vector. So taking the derivative of the tangent vector, I'm going to go over here and say, okay, negative sine t cosine t. So I'm going to have to use the product rule there. So the derivative of negative sine t is going to be negative cosine t times cosine t. I'll write it out because this is notes. Plus negative sine t times the derivative of cosine t, which is also a negative sine t, so it's just going to be sine squared t. Derivative of cosine squared t is 2 cosine t, so negative 2 cosine t sine t. And then derivative of negative sine t is negative cosine t. Alright. And if we know negative cosine t times cosine t, again, just because I don't have too much room, it's just going to be negative cosine squared t. Negative cosine squared t. Alright. Now that I have that, let's go ahead and find out what my unit normal is. So the unit normal vector is just going to be the derivative of the unit tangent t divided by the magnitude of the derivative of unit tangent t. And so we're going to go ahead and substitute, I'm going to go ahead and plug that in. And we are going to get, that's a t right there. Negative cosine squared t plus sine squared t, negative 2 cosine t sine t, negative cosine t, all over, and let's go ahead and square the denominator, or not square, but square root it. And so we're going to square the first. We're going to get negative cosine squared t plus sine squared t squared plus negative 2 cosine t sine t, and then times or plus negative cosine t squared. Alright, now we can continue to work on this, but because I already have it in the form of unit normal, and I'm just looking for, we know what is our unit normal at 0, I don't have to look at what the following function is because I don't have to take another derivative. The last part I'm going to do is do a cross product of the tangent and the normal at 0. So I'm just going to go ahead and substitute in 0 in for my t and find out what my formula gives. So in the numerator, I'm going to have cosine of 0, which is 1 squared, so it's just going to give me negative 1. Then negative 2 cosine 0, sine 0, that's going to give me 0. And then cosine 0 is 1, but then there's a negative, so negative 1. So there's the numerator when substituting in. Now in the denominator, I'm going to go ahead and do a few of those. Negative cosine squared is just going to give me, negative 1. So negative 1 squared is going to give me 1. Plus 0 squared, which is 0, plus negative 1 squared, which is just going to be 1. And so therefore, I have 1 over square root of 2, negative 1, 0, negative 1. And that is going to give me, I'll write it out as negative 1 over square root of 2, 0, negative 1 over square root of 2. Again, either way is going to be fine, but I went ahead and have written this when I went ahead and distributed in my scalar of 1 over square root of 2. So that is my unit normal at 0. And now the last thing I want to do is I want to find my unit vector of our binormal, so our unit binormal, but only at b. I'll change the color. Only at b of 0. So I'm just going to go ahead and find that b of 0 is equal to tangent of 0 cross unit normal of 0. And tangent was 0, 1, 0. 0, 1, 0. Normal was negative 1 over square root of 2. Is it 0? Yeah, 0. Negative 1 square root of 2. And now we do the cross product, and so multiplying, we get this. 1 times negative 1 over square root of 2 is going to be negative 1 over square root of 2. And then 0 times 0, so it's going to give me 0. Then we have 0 times negative 1 square root of 2, which is 0 times 0 times negative 1 square root of 2, so 0. And then finally 0 times 0 is 0. Minus 1 times negative 1 over square root of 2 is going to give me positive 1 over square root of 2. Alright, and that's it. That is our